Let's look at graphing a more complicated transformed graph. This one's a cosine. Same thing, same considerations apply to sine. And so what, according to sort of the method I'm suggesting, which is very close to the method in the book, what do we want to do? We want to find the essential parameters first. Period is crucial. Period equals 2 pi over b. In this case, b is 2. And so that's just, whoops, 2 pi over 2, which is pi. And remember, the quarter period is crucial. 1/4 p is just then going to be pi over 4. So those are going to be our steps. But when we've got shift, then that changes our anchor point, our start of the cycle. So our anchor point, we need to find the x-coordinate. That's the real crucial thing. And then the y-coordinate we can just plug in. So the x-coordinate, the crucial thing is we want to fake out the cosine function and make it think it's at the start of the cycle. So we just have to do a tiny bit of algebra. We look at what's being fed into the cosine function, and we set it to 0. The book has an alternative here of kind of manipulating this and changing it into a different kind of standardized form than reading something off. I think it's easier to remember. Fake out the function, set this equal to 0, solve. It's not that hard. 2x equals minus pi over 2. Notice that minus is important. That does relate to the way the book would do it. And so there's x equals minus pi over 4. That has a name. The x-coordinate of the anchor point is called the phase shift. It's how much it's been shifted horizontally. This case says it's been shifted left pi over 4. Okay, so we know that, taking a break from this method for a second, why do this method? We know that this is going to squeeze it, although, ooh, is it stretch it? Oh gosh, that's hard to remember. Well, here's a way to find out. This shifts it, but exactly how and what direction, how much in what direction, that's the trickiest thing. That's also something that's answered by this kind of method. This is going to flip it upside down and stretch it vertically. This is going to shift it vertically. That's a heck of stuff going on. If you wanted to do all those transformations, it would take you forever, and you might not do them in the right order, and you might not do them correctly. So it's nice to know that that's what's going to go on. It's going to be shifted and flipped and stretched and stuff like that. But to get the actual graph, it's nice to go through a procedure like this, where the basic point is to figure out exactly what points to plot, minimal set of points to plot, and then plot them carefully. Okay, so we've got our anchor point. That's the x-coordinate. Okay, now the y-coordinate will come in a minute, but to be a little more simple, let's see what else we need. The quarter period is going to be our steps. Our anchor point or phase shift is going to be where we're going to start putting in x values. We really could actually kind of go from here and just start plugging in, and we'd be good. But there's a few more things that we can read off easily. The amplitude, of course, is just the absolute value of a. Here's where that absolute value actually does something. It's the absolute value of minus 2 is 2. Okay, so we're going to go 2 up and 2 down from our center line. Ah, what is the center line? Well, the center line is always just given by the vertical shift. Whatever this function's doing, whatever complicated stuff it's doing, it's wiggling around but around 0, up and down symmetrically around y equals 0. That's what cosine and sine both do. And so the minus 3 is just going to come from the shift. Okay, so that's nice. Very easily we can read off the max and min. Okay, so it's going to go from the center line plus the amplitude to the center line minus the amplitude. So it's going to be minus 1, max equals minus 1, min equals minus 5. And so the only 3 y values we're ever going to plot for this function are minus 3, minus 1, and minus 5. Let me just emphasize that. Whoa, math mode out. Okay, these are the only 3 y values to plot for our method, because we're going to go center, max, min, center, all just back and forth, and just those y values. Okay, so that's nice to know. And so, in fact, we can start sketching those in as dotted lines. I'll do blue here. So here's minus 1. It starts to get a sense of the scale, too. Minus 1, minus 2, 3, 4, 5. So there's minus 3, there's minus 5. So it doesn't hurt to put in a dotted line for the center line, dotted line for the max, dotted line for the min. It's always going to be in this band in here between minus 1 and minus 5, and symmetrically around 3. And now we just have to figure out, where does it hit the middle? That's the midline points. Where does it hit the top? Where does it hit the bottom? Okay. Well, we've already got one of them, x equals minus pi over 4. And that's going to be where it's at the anchor point. Now that's going to be a little tricky. We're going to have to be careful about that. What about the scale on the x-axis? We can get a sense of that. We're going to be starting at minus pi over 4, and we're going to need 2 periods, so about 2 pi's worth of space. So let's go both left and right, and let's say minus pi here, and symmetrically pi here. And then here's pi over 2. Here's pi over 4. Here's minus pi over 2. Here's minus pi over 4, which we know is crucial. Okay, so that is going to be where we consider the start of the cycle. It's been shifted to start there. Now, exactly what does it do? Now we're ready to plot points. Okay. So I'm going to make a little table, actually. Let's just say... Okay. So when x is minus, pi over 4, that's the anchor. Now we have to be a little careful. What does a cosine do? It starts out at an extreme. It starts out usually high, but this is going to flip it upside down. So a minus cosine is going to start low. So let's just remember that a minus cosine will start low. And if we don't remember that, we can just blindly plug in the x equals minus 4. Let's do that. Okay. If we plug in, let's do a little scratch work. Minus 2 times cosine of 2 times minus pi over 4 plus pi over 2, all minus 3. Whew, that's a lot of stuff. But you just do it one step at a time. Okay, what does that equal to? 2 times minus pi over 4. That's minus pi over 2 plus pi over 2. Oh my gosh, what a coincidence. That's equal to 0. Oh, of course it's equal to 0. That's the point. That's why we minus pi over 4 is special. It's so that we could fake out the cosine function and give it 1. Now, so we could have shortcutted that if we'd remembered. The whole point of the anchor point is where the cosine is equal to 1. And so what we're seeing is that the minus, we get the lowest value possible, because the minus is giving a minus 2 for the cosine, and then minus 3, and that's minus 5. And so indeed, that corresponds to, if we had remembered this thing, that a negative cosine will start on the low side. And we know what the low side is. We know that the max and min are just minus 1, minus 5, so it's just going to be minus 5. Remember, these are, again, are the only 3 values, minus 3, minus 1, and minus 5. Now we're ready to go, because after a min, it's got to be a middle. The quarter period is pi over 4, so we just add pi over 4 and we get 0. The middle is minus 3. Oops. Then going up, pi over 4. The high value is minus 1. Then going up again, stepping up by pi over 4, is back to the middle. And let's see, 3 pi over 4. And then that's back to the bottom. Okay, so we can start plotting that. That's one period. And so it starts low, middle, high, middle, low, and that's 3 pi over 4, by the way. Okay, and so I can just smoothly put in the graph there. Now I could continue over here if I wanted to, but let's just, for fun, let's step backwards. Okay, and so if we step backwards from minus pi over 4, we get minus pi over 2 back to the middle, because it was starting at an extreme. Cosine starting at the low side here for minus cosine. Minus 3 pi over 4 back to the top, and then minus pi back to the middle, and then I guess I need whoops, yeah, I guess I need one more row, and minus 5 pi over 4 minus 5 back to the bottom. And so here we are, minus 3 pi over 4, minus 5 pi over 4. Middle, high, middle, low. Okay, so I've got a carefully sketched graph with all these points put in careful places, and that's something I require, is to really not just freehand a bunch of it, but we really want to know exactly where all these points are. And I've got some guidelines for the middle and the max and the min, and I've got the phase shift. Everything is there on the graph.